Okay, today we're talking about describing motion. Motion is a change in position compared to a reference point. An object is in motion if its distance from another object changes. Okay, so I'm going to show you a video clip and I want you to look at how, or we'll talk about it while we're watching it, but look at how we can tell that an object is in motion because of its distance from objects changes throughout the video. Okay, in this video we have, we're on the train tracks. We've got a camera laid in the middle of the train tracks, and you can tell that this train that's coming towards us is in motion because the distance between the camera and the train changes. It decreases, and then after the train passes, it increases. Okay, so you can tell an object is in motion when it's a change in the distance from other objects. Okay, changes in motion. The motion of objects change when the object is speeding up, the object is slowing down, the object changes direction, there's an unbalanced forces act on the object, like gravitation, friction, and air resistance. A reference point can be used to tell if an object is in motion. A reference point is any object that appears to stay in place. Okay, it's used to determine if another object is moving. So an example of good reference points would be trees, buildings, signs. So moving objects are not good reference points because you can misinterpret if something is moving or not, if the reference point is moving. So an example of this would be like if you're sitting on a bus and the other bus sitting next to you starts moving. Suddenly your bus seems that you're moving backwards, but really you are the one that's staying in the same spot. And that is a reference point that makes you feel like you're moving even though you're not. So that would be an example of a bad reference point, okay, because it is moving. In this picture, we can tell that from this picture to this picture, we can tell that the mail truck has moved with reference points like the tree, okay, or the house that's down the street. We can tell that it's gotten closer to the house and further away from the tree. Houses and trees and mailboxes are good examples of good reference points because they stay in place. Okay, here's another reference point example. In Figure 1 and Figure 2, describe the car's motion from Figure 1 to 2. Can we tell how far the object has moved? And the answer is no, because we have no reference point. But when we add in a reference point, we can tell that the car has moved past the house, which will give us, because the distance has changed from that house, we can know that the car is in motion. As an example of a good reference point. Okay, so looking around you, can you find a reference point that is stationary? And write that down in your notes. Then I want you to look outside and find a reference point that would be stationary. And write it in your notes. Okay, relative motion. Relative motion is just a way of saying that sometimes people will say different things about the motion of the same object. And this is not because one of them is wrong, but it's because they have different reference points. Okay, they've got different perspectives on it. So if you choose the Earth as your reference point, you may not be moving because you are moving along with the Earth. Okay, but if you choose the Sun as a reference point, we are moving, we are in motion because you are moving with the Earth around the Sun. We orbit around the Sun. So if we use the Sun as a reference point, we are in motion. But if you use the Earth, our placement on the Earth compared to the Earth, if you don't move, you stay in place. So that means that you would have no motion. But if you compare yourself to the sun, you would be in motion because the earth moves around the sun. Okay? And I'm going to show you a clip that talks about relative motion, or demonstrates relative motion. Okay, in this video clip, we have this guy walking on the paths at the airport, and he's staying in place compared to the reference point behind him if we keep him like with this post. But then you will see people that walk past him. So if we use the people as a reference point, they would say that he's in motion. Okay, but he stays pretty close with that post. So if we use the post as a reference point, we would say that he's not that much in motion. You know, right now he's getting away from it, but you see the people walking by, and his distance changes compared to them. So his motion compared to them, he would be moving. But compared to this post here, he's staying pretty much right there with it. So that would be saying that he doesn't have a change in his motion. Okay, and just to review, when we are measuring distance, distance is the length between 2 points, and in science, we use the metric system. Okay, and if you have a metric system, if you're dealing with a metric system, there's 1,000 meters in a kilometer, 100 centimeters in a meter, and 1,000 millimeters in a meter. And kilo means 1,000, centi means 100th, and milli means 1,000ths. And when do you use each? Well, when you're measuring with millimeters, you're going to be measuring very tiny distances, okay, like the wing of a mosquito or a grain of salt. When you're measuring centimeters, it would be a small distance, like the length of a book, a pencil, your table. When you're measuring a meter with meters, this is a medium distance, like a length across the room or the distance down the street. Kilometers are long distances, okay? These are similar to our miles, okay, as far as equal to. The length between cities across towns, we use kilometers to measure if you're talking scientifically.